It is a beautiful day for compound interest and solving for interest rates, given a bunch of information. So let's start that. So Jill was given a bond that cost $350 at birth. When Jill turns 8 years old, the bond will be worth $600. What is the annual rate at which the bond grew, assuming interest rate was compounded monthly? So let's identify a few things in this case. The important part is it says, what is the annual interest rate? So that tells us we are looking for our R value, our rate in this problem. We probably know a lot more about the other stuff than we usually do. So as we read this information, it says that she was given a bond at $350, and this is our starting value or our initial, okay? And then in the end, it'll be worth $600. There's our final. So let's plug those in, okay? So we've got $600 equals to $350. And then I'll just start adding the other stuff. 1 plus, we know that we're looking for the rate. So we put R over N. Remember, N is the number of compoundings. And the thing that it says in this case is that we are looking for the fact, we are given the fact that it is compounded monthly. So I'm going to put 12 here, and then 12, and then T. I put that in a different color because I like to highlight that. The T in this case, or time in years, is 8 years. So let's go ahead and write times 8. Once we start with this problem, we're going to start simplifying some things. You're going to notice automatically that we have an exponent, And because we have the exponent, no logarithm in this case. Okay, and that's a little sad because I love logarithms. So let's go ahead and throw this together. We'll start simplifying and solving algebraically, then we'll look at it graphically. So 600 equals to 350. 1 plus R over 12. And notice this 12 times 8. We know that 12 times 8 is 96. I'm going to get rid of that piece. After we finish that, we need to identify that in order to get to that exponent of 96, I got to get rid of that 350. So I'm going to divide by 350. Okay. And I'm going to come over here. I actually already have it. It is 1.714. And I'm going to write all three of those out. We'll get a more precise answer. 1.714 equals to 1 plus R over 12 to the 96th power. Now, I want, in order to get rid of this 96, I need to get that value to 1. And in order to do that, I'm going to recognize that, well, that's 96 over 1. So I'm going to multiply by 1 over 96. I'm going to use the reciprocal. And what I do to one side, you do to the other, except I'm going to put it in the exponent. Okay, so that all crosses out. And I'm at 1.714 to the 1 over 96 power. I'm going to add a 4 there. 1.714 to the 1 over 96 power. And I'm going to put 1.0056. I'm going to go a little bit further out. 0.0056 equals a 1 plus R over 12. And the only reason why I'm going further out is because when we do these, we'll just get a little bit more exact of an answer, especially when we look at it graphically. So now I'm going to get rid of that positive 1, subtract that 1 over, and I'm left with 0.0056 equals to R over 12. And the last step that we're going to do is get rid of that dividing by 12, which is going to be multiplying by 12. Okay, I'll cancel that. R comes out, and we need to find out whatever 12 times 0.0056 is. 12 times 0.0056 is 0.0672. 0.0672. And as we do this, remember this is a rate, okay? And it's supposed to be our annual rate. And we want to change it to a percentage. So the percent of growth, I'm going to take that 0.0672, multiply it by 100, and it moves that decimal over 2 spots, and we get 6.72% growth. And that is annual growth. Now, just to verify this, we're going to go into Desmos real quick, and I'm going to type in the original equation, which is 350, 1 plus R over 12 to the 96, except I'm going to put a X in for R, and then I'm going to type in Y equals to 600. And as we look at this, you can already tell we can already center down here. I've went ahead and did that. Now, one of the hard parts for this is just making sure that you get that exponent in there as 96 to make sure it verifies. And once we have that, we'll turn that graph on. I'll put the y equals the 600 value in there. And then we are going to look for the intersection. Now, the thing that it tells us is that our value is somewhere around 600 on the y-axis, which is right there. We can see that y equals 600. So when I do this piece, we need to make sure that we go up to the range and we go to the y-axis there, and I put some numbers below and above. So maybe 590, which is slightly low. We just need to be able to capture that value of 600. And maybe 610. And then once we're here, we are going to just zoom in as far in as we can just to verify our answer that we got algebraically. And now we're going to do it graphically. And notice our answer is 0.0675, so 0.0676. Let's go with that. And 0.0676. Okay. 0.0676, and check it out, that becomes 6.76%, and that verifies, hey, check it out, our algebra was really daggone pretty close. Beautiful work out there, did a great job, and let's go ahead and keep that up as much as we can.